Kindly unmute yourself and tell me what you see. Our moderator, can you confirm what is showing on your screen? You are not audible enough. Can you confirm what is showing on your screen?
Good evening, Doc. Yes, please.
Please.
I can see. Yes, I can see tutorial past question on SME 07 measures of central tendency from questions 1 to 4.
Okay, and on the other side, can you see Educate 01 written?
Yes, I can see Educate 01, sir.
Okay, thank you.
Yes, sir. Yeah, you're welcome, sir.
So it is 5:03. We have to start now. We just have 1 hour to solve as much as we can solve of these problems. So the whole of this problem is on mean of ungrouped data sets. So some of the questions are very simple, some are conceptual, and then some of the questions require little more explanation. So let's get started. The very first question in there, so it says, look, 801, and today's date being the 5th of July 2024. The very first question in there, it says, calculate the, given the data set, calculate the mean. This is one of the simplest questions that you can come across in this course. Given the data set, calculate the mean. We have the data set 12, as it is written. Perhaps I don't have to write this again. So from what you were taught in class, the mean of a data set of this nature is just defined as the sum of items over the number of items. So that is the arithmetic mean. So in this case, you're having 5 items in a data set. So you find the sum and then you divide by the number of items, which is 5. So the solution to this problem will simply be 12 plus 15 plus 10 plus 18 plus 20, and then divided by 5. This we might need you to have your calculator by your side. Let me also see if I can get mine up here, because we will need a calculator in some of these things perhaps. So what you need to do now is just to find the sum of the numbers that you have on the screen. So what do you get from here? I have 12 plus 15 plus 10 plus 18 plus 20. And this gives 75. Is that what you get as well? I have 75 here, then divided by 5. And of course, 75 divided by 5 is nothing but 15. Thank you. So the right option there is option B. The answer is there. Okay, so let's go to the second problem. Or perhaps we should take the odd number first. If time permits, then we come back to even. So in this case, I'm gonna take question 3 instead of question 2. So let's take question 3. So question 3 says, a data set has the values. Oh, what does it mean? Almost as the first one. A data set has the following values. What is the mean? You sum the items and then you divide by the number of items. So in this case, we have 22 plus 25 plus 30 24 . 2, 3, 4, 5, 6. Yeah, divided by 6. So please, you have to also open your eyes very well, because some of these things I've not done them before now, so you are just doing it together. So feel free to make some comments on something that goes wrong. So you find the sum. Has anybody done that? Why I also try to punch my calculator here. You have 22 plus 25 plus 30 plus 18 plus 27 plus 24. From my hand, I got 146. Is that what you get to? If you have a contrary answer, let me know. Otherwise, we assume everything is fine. Is okay, everybody? So you just divide 146 by 6. And with that, I got 24.33. Did you get the same thing? And I think the right answer is there. That is also option B. Okay? So feel free to stop me if I'm too fast. Let me know. And if you need further explanation, kindly unmute yourself and speak. This is very important. Your silence means, to me, everything is fine. So I go to problem number 5. Problem number 5 is also very direct.
Good evening, Doc. Okay.
Please go ahead.
Okay, so sorry, sir. So from what I got 136. So when we divide 136 by 6, so it gives us 22. It gives us 22. The option A. It gives us it gives us 22.67.
Okay, please. We need another person to confirm that addition. We have 22 from my hand plus 25 plus 30
yes,
plus 18 plus 27, then plus 24. I got 146.
Yes.
It's 146, the right answer.
It's 146. Thank you very much. So perhaps
yes, the right answer is 146.
Thank you very much. So we go to problem number 5, where it says, calculate the mean of the data sets 7, 14, 21, 28, and 35. We just find the mean 7 plus 14 plus 21 plus 28, then plus 35, and then divided by number of items 1, 2, 3, 4, 5. Okay, it's also very simple. We just punch the calculator to get the sum. Then we have 7 plus 14 plus 21 plus 28 plus 35, which I got from here
105.
Thank you very much.
Yeah.
And 105 divided by 5 will give you 21. All right. I think we also got the answer. The correct option there is option A. These are easy questions. Perhaps I've chosen the easy ones. So by the time we come back to the even numbers, we take the odd ones maybe. So we go to the next problem, which is problem number 7 now. So taking odd. Problem number 7, it says again, fine. Okay, look at this one. For the data sets 9, 11, 13, 17, and 19, if one more value, 15, is added, what is the new mean? This is just a simple way of asking you to find the mean of all the values you can see on the screen. You are given 5 numbers before, and if one more is added, what is the mean? Okay, so again, your mean is the sum of items divided by the number of items. So you have this to be 9 plus 11 plus 13 plus 17 plus 19 and plus 15 divided by number of items 1, 2, 3, 4, 5, 6.
Divide by 6.
Divided by 6. Thank you. So now then the addition, please. Kindly work on the addition. And let's have it. From my hand, 9 plus 11 plus 13 plus 17. Thank you. Plus 19, then plus again 15. 84. Thank you very much. Yes. We got 84 divided by 6. And 84 divided by 6 is what?
71.5.
It's 14.
I got the answer to be 14 here. Okay.
Yes.
So the answer is 14. So
The
take
answer
note.
is B, sir.
The answer is B. Thank you. Please, you have to be very careful when you are pressing the numbers and when you are doing your division, so that you don't press the wrong digits in order not to have the wrong answer. So this is clear. Then we go to the next problem. That is problem 9. So we have to take it a little bit gentle here. Look at this problem. It says, if the mean of the data set 18, 22, 24, 26, x is 24, what is the value of x? Can you see this one? If the mean of this data set is 24, what is the value of x? So this is also a simple arithmetic problem.
Okay.
We use our definition for mean, and then we proceed from there. Suppose we want to compute the mean of these numbers. What do we do other than just adding the numbers together and divided by the number of items? So we have 18 plus 22 plus 24 plus 26 plus x divided by the number of items, 1, 2, 3, 4, 5. But we were told that this mean equals to 24. We have the mean. Do you see this? So to proceed from here, what do? We have these numbers together. So our moderator, kindly do your work. Somebody is disturbing. 18 plus 22 plus 24 plus 26. Here I got 90 plus x divided by 5 equals to 24. Do you get the same thing? When you add the first 4 numbers together, you get 90. And your x is what you're looking for. You don't know it. So you leave it in here. Excellent.
Yes.
So how can you now simplify this further? By saying 90 plus x equals to 5 times 24. I hope this is clear.
Yes, sir.
Excellent. So, and then what do you now have? 90 plus x equals to 5 times 24 is 120.
120.
All right? Perfect. So that means your x equals to 124 minus 90.
Minus 90.
I hope this is clear.
Yes,
Simple arithmetic. Remember, we started with this arithmetic in this course. So x equals to 30.
30.
So the right answer is 30.
30. Yes, sir.
Is it okay, everybody? Are we fine?
It's okay, sir. Yes, sir.
Thank you very much. So this is the whole solution to the problem. You use your knowledge of arithmetic, you add items together, you divide by the number, and then you use simple arithmetic to arrive at your final answer. So that is problem 9. Let's now go to problem 11. Problem 11 says the mean of a data set. Okay, this one is a very easy conceptual problem. The mean of a data set is most affected by dash. A, the mode of the data set. B, the median of the data set. C, extremely high or low values, the outliers. Then D, the range of the data set.
D.
The answer is what? B or D?
D.
Okay. Any
The
other
answer is
answer?
D. D, sir.
The answer is D. Okay. Any contrary opinion?
No.
You cannot contradict
Let them
yourself.
answer now.
Another
It's
person
D.
should talk. Any other opinion?
No.
Read the question again. The mean of a data set is most affected by the mode, the median, the outliers, or the range?
It's the range.
The range. Are you sure our attendant, our participant today, they are alive? Or they are just chilling? They are
Yes,
just
sir, we
online.
are alive.
We
They
are
alive.
here, sir.
So what I'm saying here is that I have a contrary opinion.
Okay.
The answer is not the range.
Yeah.
In fact, the range cannot in any way affect the mean.
Okay.
In fact, more importantly, they belong to different categories of measures in statistics. Range is a measure of variability. Mean is a measure of central tendency.
Okay.
Do you see it now? So there is no way the range will affect the mean. No way. Aha, we have knocked out that's your option. Are you gonna change your mind now?
Extremely high or low value.
Yeah, that is the correct one. Extremely high or low values, which we call the outliers. They mostly affect the mean drastically. Let us pick a simple example. What is the mean of 1 plus 1, 2, and 3? The mean is just this divided by 3, yes, which is
this over 2.
Which is 2, all right?
Yes.
Now just imagine that these 3 data sets, by the time you are entering it, you made a mistake. Instead of 3 in your data set, you put 30. Okay? So what is now the new mean? 1 plus
11.
2 plus 30 divided by 3. Can you see the difference?
Yes, sir.
Can you see how big the difference is?
Yes, sir.
So this type of data, the other values, they are 1, 2, 1, 2, and here you're having 30 is an outlier, extremely high value. It will distort your mean. Just imagine it is not 30, it is 300. 300. You know how big the mean will look like now? 101. Yeah. That will be the mean.
Yes.
So this type of extreme values, they affect the mean a lot. Range don't affect the mean. It's the least one on this list that affects the mean, the range. So the mode, it affects the mean, but the effect is not as high as that of the outlier. Take note.
Okay, sir.
Thank you very much.
Thank you.
All right, we proceed. This is a conceptual problem. So problem number 13, that's the next one. It says,
what is the correct answer, sir?
The correct answer is C, extremely high or low values.
Thank you, sir.
All right. The next problem, in a data set, if all values are multiplied by a constant. I'm not sure if the current teacher actually explored these things when he was talking about the mean of ungrouped data sets. Look at it again. If a data set, in a data set, if all values are multiplied by a constant factor, the mean of the data set will be dash. A, remain the same. B, be multiplied by the same constant factor. C, increase by the constant factor. D, be divided by the constant factor. What is the answer?
B.
B, be multiplied by the same constant factor. Any contrary opinion?
No, yes, sir.
A, sir.
A, remain the same. Interesting. Any contrary opinion?
Yes, sir.
Is
C.
C.
Is C.
Increase by the constant factor.
Constant factor. Yes, sir.
Hi, this class is completely divided now. So this class is completely divided now. So we're having three groups. Some people said A, some people said B, some people said C. Any other contrary opinion?
The answer is A, sir.
You still remain resolute on your option. Okay. Let's give chance to others to also speak about it. Another contrary opinion? Okay. The correct answer is B.
Wow.
Okay. The mean is multiplied by that same constant factor. This is a problem of transformation.
Okay.
When you transform your data by multiplying by a constant factor, the mean is also multiplied by that constant factor. Let me break it down for you. Look at this data set, 1, 2, and 3, to make it simple. The mean, what is the mean of this data set? Tell me. We just did it before. The mean is what?
2.
X bar.
2.
Thank you. X bar equals to 2. Now, this guy is now saying, if we multiply each value in this data set by a constant factor, suppose the constant factor is 3. Is 3. Suppose the constant factor is 3. So your new data set will now be 3 times 1, 3. 3 times 2, 6. 3 times 3, 9. Is it not? That is your new data set. So what is now the mean of this data set? 3 plus 6 plus 9 divided by 3.
3.
Okay, what is 3 plus 6? 9. 9 plus
9.
18. 18 divided by 3 equals to what? 6. Okay? What is now the difference? Our X bar of the transformation, X bar 1, equals to what? 6. Can you now compare this with this one? You know, 6 is just the constant factor 3 multiplied by the mean. 3 times 2, 6. Do you understand?
Yes, sir.
So if you multiply
Yes,
all
sir.
values by a constant factor, the mean of the new data set will be multiplied by the same constant factor. That is
Okay.
what you are saying.
Yes, sir. So 2 times 3 will still have 6.
Yes. And you can go a bit more if you like. If you have x1, x2, then x3. These are arbitrary numbers.
Yes.
The mean of this x bar equals to x1 plus x2 plus x3, okay, divided by what? 3. Okay? So if you now multiply x1 data set 1, d1, d2, okay? Let us multiply each of d1 by a. This will give us ax1, ax2, ax3.
All over 3.
Yeah, what is the mean? The mean of this one will be ax1 plus ax2 plus ax3 divided by 3. So this a is a common factor. You can bring it out into brackets x1 plus x2 plus x3 divided by what? 3. Can you see? Which is the same thing as ax bar. So when you multiply data set by constant factor, the mean will be transformed by just simple multiplication of that factor. This is very important. Take note. Is it okay, everybody?
Yes, sir.
Yes, sir.
Thank you, sir.
Thank
We
you.
got it.
So let's go to problem 15. So problem 15 says you can just mute yourself. It's only when you want to speak, then you will mute, so as not to have sound interaction. Okay, now problem 15 says the mean of a data set is a measure of dash.
It's A.
Central tendency. This one is the simplest question we can ever get. Yes?
Central tendency, sir.
Perfect, ma'am.
A.
All right, A. Let's go to problem number 17. Look at this one. Let's see this. A data set contains 10 values, each equals to 7. And another 10 values, each equal to 9. What is the mean of the data set? That's question number 1. And how does the addition of an outlier of 100 affect the mean? A, the mean increases slightly. B, the mean increases significantly. C, the mean decreases. D, the mean decreases significantly. What's the correct option before you calculate the mean? You have to unmute yourself this time around before you speak. You need to unmute yourself before you speak.
B, sir. The mean increases significantly.
Thank you. And I think we don't have to debate this. How do you know that? Can you explain, madam? How do you know?
With the one we solved earlier.
With the one we solved earlier, but you have to be careful here. Look at the data set given to you. You're having 7 10 times, 9 10 times. So these are small numbers, right? 7 and 9. When you now bring 100, when you now bring 100, 100 is a very big number.
Yes.
So when you introduce 100 into the data set, it will inflate the mean. Is it not?
Yes.
Because when you look at 7 and 9, the mean of that data set will be around that range. By the time you introduce 100 like this, it will just
The mean is 8.
So the mean is 8. Thank you. Can you see that? The mean is 8. So when you now introduce 100, it's going to inflate the mean. So in that case, we find out that it's going to increase the mean significantly. Thank you very much, madam. The answer is B, but that is the explanation.
Thank you,
All
sir.
right. Let's now go to problem number 19. Okay, the data set, we have done something like this before. The data set 6, 8, 10, 12, and x has a mean of 11. If x is a positive integer, what is the value of x? Okay, so we use our knowledge of arithmetic mean. 6 plus 8 plus 10 plus 12 plus x divided by 1, 2, 3, 4, 5 equals to, we are given the mean. The mean is what? 11 equals to 11. Is it okay? So then you just add this together. So what is 6?
36
plus 8 plus 10
plus 12
plus 12. 36, thank you. We have 36. No, not 36x. 36 plus x. Okay? Equals to 11. Is it okay?
Yes, sir.
So 36 plus x equals to 5 times 11.
Okay.
36 plus x equals to 55.
55.
So x
55 minus
equals to, thank you, 55 minus 36. And what is 55 minus 36? Tell me.
19.
55 minus 36 is what? It's 19. Is this okay, everybody?
Yes, sir.
Yes, sir.
Very easy. Perfect. So we have just finished with the odd problems. So we can now go to the even problems. Okay?
Yes,
all right.
sir.
Let's see how much we can do before it is 6 o'clock. All right. So now we go back to problem number 2, which is the first even number. If the mean of the data set you have it is this, what is the missing value in the data set? Look at this problem. If the mean of the data set is 12.8, what is the missing value in the data set?
It's almost the same what we did.
Exactly. But in this case now, the missing number is not specified. They don't give us X. So we are the one to say, let the missing number be something.
The X. Yes.
The X. And then we include it into our data set, we find the mean, and then we go on from there. So we start by saying, let the
missing
number
be X.
Okay? So the mean is 12.8. So we have 8 plus 11 plus 13 plus 14 plus 18, then plus X divided by 1, 2, 3, 4, 5, 6 equals to the mean we were given, 12.8. Is it okay? Is it okay, everybody?
Yes, sir.
Yes, sir.
Now we introduce what is missing. So we now add this together. 8 plus 11 plus 13 plus 14 plus 18. I got 64. Did you get the same?
Yes, sir.
Yes, sir.
64 plus X divided by 6 equals to 12.8. Please feel free to stop me if something is not clear. Then we explain before we move further, okay? So what we do now, we say that 64 plus X equals to 6 times 12.8. Is it okay? And then we have 64 plus X. Let me write this. 64 plus X equals to 6 times 12.8. I got 76.8.
76.8.
Is it okay now?
Yes, sir.
Yes.
Do you get the same as 76.8?
Yes, sir.
So our X will be 76.8 minus 64.
Minus 64.
What do you get?
The answer is 12.8.
12.8.
So the missing number is 12.8. The same as the mean.
As the mean.
Same as the mean.
Yeah. Okay.
Yes, sir.
And the option is the option C. Are we okay, everybody?
Yes, sir.
Yes.
Thank you. Any comments from the audience?
No
Okay.
comments, sir.
So we can go to the next problem, which is problem number 4. And it says, the mean of a data set with 9 values is 18. This one is interesting. If one value, 27, is removed,
Okay.
what is the new mean of the remaining data set? You see it now? Are we okay? The mean of a data set with 9 values is what? Is 18.
18.
If one value is removed, and that value is 27, if 27 is removed, what is the new mean of the remaining data set? All right. So let us translate this sentence by sentence.
Okay.
The first sentence, it says, the mean of a data set with 9 values is what? Is 18.
18. We need to find
So
that one first.
let's deal with this one first. Thank you. So what is the mean? Sum of items over number of items, right?
Yes, sir.
So sum over
Sum.
number, but that number is 9, okay? Equals to what? 18.
18.
Is it okay?
Okay, sir.
So from here, we can say sum
18.
is actually equals to 9 times
9
18.
times 18.
18.
I'm still
Yes.
interpreting only the first sentence. So,
Yes, sir.
Yes.
So
Then
what is 9 times 18?
162.
162.
So sum equals to what? 100.
162.
Okay. We are through with the first sentence. The second sentence now says, if 27 is removed.
Minus 27.
Okay? Yes, what is the new mean? If 27 is removed, that is this sum we have
162 minus
27. I want to know the mean.
Yes.
Divided
Yes.
by what is the number here? 8
8.
equals to the mean.
Okay.
Equals to the mean I'm looking for. Let me write it in
Yes.
words. Equals to what?
Mean.
Where is the 8 coming from?
Good. No, we remove one number from 9 numbers.
9. So it
Wait,
remains
okay.
8 numbers now.
8.
Yes.
Do you understand it now?
Yes, sir. Thank you.
We remove one number from 9 numbers, it will remain 8.
8, yes.
And the sum, we are removing 27 from that sum. The sum of the remaining one will be 27 minus the sum minus the 27. Is it okay?
Sir.
Yes, sir.
So we can do this now.
135.
So our sum is a 162. We have got
162 minus 27
divided by 8. This is our mean. So what is 162 minus?
Sir, I don't understand.
Yes.
Okay. The very first thing that you need to do is to understand it sentence by sentence. Do you understand the first sentence?
Okay.
The mean of a data set with 9 values is 18.
16 points.
And you know the mean is sum of items over number of items. Okay?
Yes, sir.
Let me use a different plan. So it's sum of items over number of items. So that's why we wrote sum. We don't know the sum. We just wrote sum. But
Yes,
we
sir.
know the number because there are 9 items.
Okay, sir.
That's why I put 9 here. And the mean is 18 equals to 18. That means sum divided by 9 equals to 18. Is it okay?
Yes, sir.
This aspect is very simple. We are still dealing with the first sentence. So that means sum equals to 9 times 18. I want to believe it's clear up to this point.
It's cross multiplication.
Cross
sir.
multiplication.
Yeah, just multiply.
Yeah.
Okay. And
Yes.
then 9 times 18 is 162. So sum equals to 162. Sum.
Yes, sir.
Okay. The sum
Yes.
of the original data set. Okay.
Yes, sir.
So the second sentence now say, if one value is removed from this sum now, if we remove one value, that one value is 27.
Yes, sir.
If we remove 27, what is the new mean of the remaining data set? You know, for the remaining data set, if you want to calculate the mean, is sum of the remaining data set divided by the number. Okay?
Okay,
Now,
16.88.
So sum of the remaining data set, if you want to know it, just remove 27 from the sum of everybody. You will get the remaining. Is it not?
Yes, sir.
Yes, sir.
So sum of the remaining data sets is sum minus 27. And since we are removing 1 from 9 numbers, the number will become 8. It's no longer 9 of the remaining data sets. So, but we know from here that sum is 162.
Yes.
So we just put it back. Sum is 162 minus 27. Is it okay now?
Yes, sir.
Yes.
So what we are now saying is that 162 minus 27, what is the answer?
135.
135. 135 divided by 8 is equal to the mean of the remaining data set. So the mean of the remaining data set equals to what?
16.875.
16.88.
16.88.
Okay, that
is it
is
correct?
all.
Yes,
sir.
That is all.
The answer
Yes,
is
yes.
A.
Excellent, sir.
Thank you.
Yes. 16 point. Thank you very much. All right. So this is clear to everybody. If you see this in your test now, you should be able to trash it.
Yes, sir.
And your test is fast approaching, probably next month.
Yes, sir. Thank you, sir.
Take notes. All right. So we go to the next problem. That is problem number 6. It says, if the mean of the data sets is 16, what is the value of X? I want to believe we should be able to do this to save our time, because we have worked about 3 examples on this now. So to save our time, I will leave you up to this to do by yourself. Okay.
Yes.
I don't know the right answer until I also work it out. So let's go to the next problem. Problem number 8. The data set 3, 5, 7, 9, 13, 11, 13, and 15 has a mean of, this is the simplest question you can get. And we have worked like 3 examples on this too. Please work it out and get the answer. I don't know the right answer now until I work it. Okay. I want to go to problem 10. This is very interesting. The mean of a data set is 40. I want you to pay attention.
Okay,
if
sir.
5 more values, each equal to 45, are added to the data set, how does the mean change? A, increases. B, decreases. C, remains the same. D, depends on the number of values in the original data set.
That's deal.
I'm waiting for your answer.
D.
Me,
D.
I chose this.
You chose D, okay? Any contrary opinion?
Yeah, I chose C.
You chose remains the same.
A, sir.
Any other? A. Somebody say A increases. So we have 3 options now. Who is going to choose B? Anybody? Nobody's going for B. Okay, without mixing words, the right answer is A. But the question is why?
Yes, correct.
Now look at
Which
it
correct?
critically.
Said B before, madam. we're just electing.
So the
It's
question
not
is why.
selective.
So you have to be careful because you don't just be selecting. You may have ad block. Out of 10,
Obviously.
you will guess one right, and that will not be palatable. So you need to have reasons for what you choose. So the answer is A, and why? Look at it. The mean of a data set is 40. Okay? If 5 more values are added, but these 5 more values we are adding, they are all equal to 45. And you can see this 45 is higher than the original mean. Is it not?
Yes.
Is higher. The 5 values we are adding, each of them is higher than the original mean. Definitely, they will move the mean a little bit forward. The mean will increase. It cannot increase. It can increase if they are far lower than the original mean. That's the time it can decrease. And it cannot remain the same because it's not the same as the mean. So take note of that. It is going to what? Increase.
Increase.
Thank you. So the right option there is
Thank you,
option
sir.
A. Let's now go to the next problem. That's problem 12. If the mean of a data set is 20, this is another interesting one. If the mean of a data set is what? Is 20. And each value in the data set is increased by 5.
That's 25.
That's
We are
25. Yes.
I have 25 already.
25.
What will be the new mean?
B, 25.
B, sir, 25.
Yes, 25 is the answer. When you
Is the
add back
answer. Okay, any contrary opinion?
No, this one is clear.
no, sir. It's clear.
If the mean of a data set is 20 and each value in the data set is increased by 5,
The mean is increased by 5.
what would be the new mean?
$25.
25?
Yes.
Why?
Yes, sir.
Why is it 25?
Because
Sir,
you
sir,
add
it's
5.
25.
You just add 5 to the mean. Remember, the
Yes.
5 is added to the data set, to not the
Yes,
mean.
sir. The original mean is 20.
And it is added by 5.
That means all the
No,
numbers
each
that
of the
added up.
values that 5 was added. Oh.
Yes, it's all the
5 is
values that
added
5 was.
to the values, not the mean.
The same numbers has increased by 5. So it's all the numbers has changed to 25, 25 now. Divide by the same, you have the...
No, wait. The mean of a data set is 20. It does not mean that each of data set is 20.
Yes.
Let me tell you this now.
Okay.
19 and 21.
Yes.
The mean of this data set is 20. Do you agree? Just 19
Yes,
plus 21 divided by 2. You can see that this one is not 20. This one is not 20.
Yes, sir.
Yeah?
Yes, sir.
Sir, I don't understand. I don't understand.
You don't understand what?
No, 19 plus 21
how that 20 come? You say 9 and 21.
19 and 21. What is the mean? What is the mean of these two numbers?
20.
Okay.
It's
20 is 20, sir.
You are agreeing with me that it's 20?
Yes.
I think he's trying to ask why we get the 19.
No, the point I'm
just
trying to
brought up
explain is that because the mean is 20 does not mean each of the number is 20. So what you're now saying, that if you now add 5 to this, what is the new mean? 19 plus 5. 21. Okay, 1 minute.
26. 24 plus
21 plus 5. So what is the new mean? This is going to be 20 what?
5.
24 plus 26 divided by 2. What do you get?
50 divided by 2.
50 divided by 2. So what do you have?
25.
Where it comes from. So this is where the explanation to your answer, this is where it comes from. It's not from just add 5 to the mean. And this is another transformation. This is another what? Transformation. This is when you transform a number by shifting it. Remember the one we did before is by multiplication. When you multiply each term by a constant, the mean is also multiplied by that constant. When you add a constant to each value, then the mean will also be added with that constant. Do you understand what I'm saying?
Yes, sir.
Yes, sir.
If you have a data set like this, x1, x2, up to xn, okay? This is a data set. If you now have x plus a constant, a, that is ax1, ax2. So this is 1 minute. This is multiplication, but you want to do addition. x1 plus a, x2 plus a, dot, 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 xn plus a. Okay? So what this is telling us that the mean of this one, the mean of this, that is xa plus capital A bar, the mean is going to be the mean of the original plus the constant A.
Okay. Yes,
plus
sir.
the constant A. So this is what, this is the general rule. This one is the general rule.
Understand.
Yes. I expect this to be covered in class. Okay? And the one we did before is when you multiply. Instead of saying x plus a, you now say ax. Ax. That is, you are multiplying each number and data set by a constant. ax1, ax2, dot, 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 axn. So the mean of this number, of this data set, is going to be that constant multiplied by the mean of the original data set. Okay? So please take note of this. These are some of the technical problems, you can have in the exam that will make you think a little bit before you choose the option. Take note. All right, so let's move. The next problem is problem number 14. The arithmetic mean is too easy. Tell me the answer straight away.
The arithmetic means it was known
as the average.
Average. Yes.
Very, very easy. Oh yeah, maybe the last question for today. Just see have time, or I should just keep this difficult question. So question number 16. Let me change my pen back to white.
Okay.
Problem number 16. Look at this attentively. Consider a data set with the following properties. The mean is 50. The median is 45. And the mode is 40. What can be inferred about the shape of the data set distribution? Shape. A, symmetric. B, positively skewed. C, negatively skewed. D, uniform. Wow.
Okay. It must be negative.
I've not gotten to this side, sir.
Is well, I guess it's negatively skewed. Because the mean is more than the media and the
Madam,
okay.
you have gotten to this far. What do you mean? You have gotten to this far. Maybe this will be a task for you to think about. But let me just brief you something. You see, for distribution, you can have it to be normal. A normal distribution is a bell-shaped.
Yes.
A bell shape like this. Okay, just manage the drawing. This is a bell shape. In a bell shape, the mean, the median, and the mode, they are equal.
Yes.
Okay, mean is equals to median and is equal to mode. Mean, median, the mode, they are equal. All right. So this is a normal distribution. Normal what? Distribution. Is it okay, everybody? Now we now have a distribution that is not normal. If it is not normal, it can be positively skewed or negatively skewed. All right? Positively skewed, it means at the beginning,
it rises.
Thank you. And then it's maybe that is not even good enough.
Yeah.
At the beginning, or let me use a different color. Possibly skewed. Is red okay? Can you see the red clearly?
Yes, sir.
Okay.
Yes, sir.
Now look at this. This is positively skewed. At the beginning, it's, you see, there are a lot of people that fail the course. Only few people pass. At the beginning is where the concentration is, like 70% fail the course. They got F. And only few managed to pass the course. This one is called positively
skewed.
Okay, skewed. Positively skewed. This is not normal. Okay? All right. So in a positively skewed distribution, where is the location of the mean, the median, and the mode? This is the point that we need. All right? Number one, the mean, the median, and the mode, they are not equal.
Equal.
Okay? They are not what? Equal. Perfect. And in a positively skewed distribution, you will find out that the mean is higher than both the median and the mode.
Yeah.
Okay. The mean is higher than both the median and the mode. Let us use this typical example given to us. Suppose I want to locate the mean. The mean, let me say my mean is here, 50. This is the mean. You will find out that the median is what? 45. Is below the mean. And the mode, the one with the highest frequency, you remember that? That's what the mode is. The mode is what? What is the mode? The mode is 40. Let me redraw the distribution because this is not correct. The mode is 40. It means the peak of the distribution is at 40. So the peak. Do you see this? So the peak is 40. Okay, so there is no way this distribution is not going to be skewed positively. So this is for positive skewed. Let's go to negative skewed. Let me get another pen. A negatively skewed will look like this, which we call the left right skewed. At the beginning, it is skewed, the left, and at the end, it is concentrated. Okay? Most of the students got A in the course. A everywhere. And only people get F. So this is not it's not normally distributed. And this is what negatively skewed distribution. Negatively what? Skewed. Okay. So you expect here for the mode, because the highest this thing will be somewhere here. The mode, you expect the mode to be higher than the mean, which is always central in the middle. So the mode is expected to be higher than the mean, and also the median can also be higher than the mean. So in this distribution given to us, it is positively skewed and not negatively skewed. Yeah. Number one, it is not normal, because in the normal distribution, the three of them must be equal.
Equal, yes.
Yes. Positively skewed, that is where you have the mode and the median less than the mean. And negatively skewed, you have the mode and the median greater than the mean. Thank you. I think it is a convenient place to stop today.
So,
Thank you,
Is it okay, everybody?
Thank you, sir.
What is the answers?
Thank you,
The
sir.
answer we just said it's possibly skewed. Is B. The right option is B.
Thank you, sir.
Thank you, sir.
All right. So thank you very much. We'll meet again probably next week or when I will inform you depending on the progress in your class.
Okay, sir.
All right. So all the best.
Thank you.
Sir.
We enjoy your lessons.
Oh, thank you,
Thank you, sir.
You're welcome.
Thank you, sir.
Thank you, sir.
God bless you, sir.
All right.
Thank
Bye
you,
bye.
sir.
Thank you, sir. Bye-bye.